So I'm not sure if you're all familiar with the composable code base, but I will not go into much details regarding the solution and improvements we get there. But just to give you a small context, like this, if we decide to work on this, it's gonna be a big initiative that will take a lot of time to execute, and probably we will need to collaborate with like different teams and a lot of people, because it requires some architectural changes. But what we did previously, like we created a blueprint and we created several proof of concepts, and the idea, general idea, is to like not load code and dependency where we don't need it, because currently even in Sidekick we load like everything: GraphQL, Grape API, controllers, etc. So with this solution that is proposed, we, in proof of concept, we measured the potential impact and improvements that we achieved, and it showed really promising results. So the idea that we are trying here, like the goal here is, yes, this initiative like showed like huge improvements, and it's, but on the other hand, it's really big. So we are trying here to better understand the impact of those improvements on, like, I don't know, our self-managed customers, but also to better understand the overall impact on the GitLab.com, on our infrastructure, because if we want to push this forward, I guess that people would like to know like how our customers are going to be impacted. Are they going to like feel the difference? Is it going to behave faster? Is our infrastructure cost is going to reduce significantly, or I don't know. So for example, but unrelated to the initiative itself, like I think it will be beneficial for our team to learn to better like look at these metrics and better understand. For example, if we find out that we will save, I don't know, 200 megabytes for Sidekick per Sidekick node, what does it mean on our infrastructure and on GitLab.com? Or if we are going to save like GC cycle time and save some virtual CPUs, like 2 virtual CPUs, what does it mean on the GitLab? And for example, I don't know, the boot up time, it's really interesting, but I'm worried, like, yes, people save the boot up time, but for Sidekick nodes only and not for Puma. And we will see here, for example, this is all more, it's not just related to the Sidekick. We will see improvements on other nodes as well, for example, for API node, but web nodes will probably stay unaffected. So if we do an improvement on Sidekick nodes and web stays the same, I don't know how to judge, like, is it good enough and is it worth it? And I don't know, I think that you understand like what I mean. So I think it will help for our team to better understand, even for the future initiatives, how this will impact. Please, Camille.
I think you should look at that not from these specific savings, because this is like very specific approach that we took as a shippable thing, but rather look at it from the long-term perspective. Effectively, it's like decomposition. It's not the composition of the database, it's the composition from another perspective, from application code base, that is like more modularized and more selective on what you need. So you're saying Sidekick Puma, these are like some numbers that we kind of want to see, but if we have good infrastructure for that, it actually allows you to support really like very big decomposition efforts that, for example, you run very minimal Puma server that's, for example, only authentication service. Something that today in any reincarnation that we need some part of the stack, we need to run the whole stack, because we don't have infrastructure to be selective. So Savings are great, and this is probably something that gives you a strong benefit. But really, like the long upside is like you actually start to become very selective on what you run and what you need, what you load, and if at some point you would really have, let's say, have a need for having a separate authentication service, you're probably scale that to 10% of what we today run on the Puma, because it's a very small portion of the whole application. So I'm not sure if you also, Nicola, remember, like we took Sidekey, removed from the Sidekey process because it seemed like the simplest. But technically, you could do this slicing, say that you have Puma controllers, Puma API, Puma GraphQL, and basically you are kind of slicing more closely how you run the infrastructure, and probably you kind of achieve the same type of saving, like, I don't know, 20-30% on tutors of these processes by being just more selective. Today we just don't have anything that would really allow us to be selective, even though in the infrastructure we run a very specific components that are just a subset of the application and only need a subset of the runtime to function. So I think like the best long-term vision is like, look how you run today on the infrastructure. Try to estimate what is the portion of, like, let's say, the stack, the slice of the infrastructure, and this kind of really gives you maybe like a picture. If we would follow this pattern for like 2 or 3 years, we could maybe have 4 or 5 components, small components that are very specific, and each of them really is like 50% of what is today. So maybe this is a better way to look out from the long-term perspective, because what the numbers we have is like, it shows that if we follow this direction and if we do this kind of slice, maybe this is the easiest slice to do initially. This is what the numbers we get, like, let's say in the first iteration. But in the grand picture, if you say if we have Puma API, Puma GraphQL, Puma Action Table, Puma controllers, Puma Git, because we have, I think, also separate Unicorn running for, separate Puma running for Git. We have different Sidekey workers with just slices of the classes. It actually can give you like very nice benefit overall of probably shrinking each of these processes by half. And I mean, by halving of the memory usage, but the load time is exponentially better. It scales more significantly than runtime. So I think this is really my perspective about the benefit of the composable code base. That maybe this is really how we should probably try to estimate that.
Thanks for the input, and I agree, but also I found it a little bit difficult to predict something like that, because yes, we like currently have the the API Puma server, which actually doesn't load only the Grape API, but that one is maybe more or less easy, but it's also hard to detect which components we could extract in the future, and even if it's gonna be possible. And I'm not sure that I can stand and promise that we will not end up by having, I don't know, 90% of the code still being the common one. So this is a little concern that I have. So yes, it's really great, and even maybe
So for example, let's say like we discussed like Puma Sidekey. We today do a lot of wasteful stuff with loading all Sidekey workers with all dependent services. even though we don't really need them in the Puma process. In the Puma process, we only need a class definition with a way how to asynchronously schedule a job. You don't really need anything that is like between side key worker implementation, because Puma process needs, for example, side key worker declaration of execution criteria, but you don't really need the implementation between side key worker implementation and models. And like you have like a lot of layers in between, which is like services, sometimes maybe finders. We don't really need, for example, to load that. And very often these services are one-to-one overlay worker or many workers. So we didn't investigate that, but this is like another thing that you could really consider. Like out of the current side key workers, since they live in the separate process in the side key, you kind of split and create a stub definitions of these workers on how you want to run them in the Puma. And this is probably where you get this another 20% on the Puma process alone, probably very easily because of our architecture. There are definitely like some blocks that we cannot really disconnect easily, which is, I guess, like all relations between models, but services, concerts, controllers, finders, serializers, a lot of stuff for the GraphQL. This actually has pretty defined context of the execution. The problem today is like it's like a single bug. It's not annotated, but we've been doing annotation for various reasons for quite some time. So maybe, I don't know, some kind of testing should help us to define what you need in the side key environment versus what you need in the Puma, or maybe you kind of move files around to create this separation and create like automatically these stubs. I started to go into like implementation details, but I think this is one way to estimate that. Really, like you have like clear outliers, which is like you don't need GraphQL implementation mostly in the side key. You maybe need like the declarations. You don't need side key workers implementation and like all related stuff. You only need like declaration how to know how to schedule that. There is actually like a ton of room to improve how we did stuff. It's raised by definition, it's like monolithic. It doesn't make it easy like to be specific on what you need in the given context. So
Camille, when you talk about this decomposition, are you thinking more about separating concerns like you are mentioning Sidekick, GraphQL, different kind of workers, and also perhaps like would you want add on top of that perhaps concerns like now we have features like, I don't know, error tracking that doesn't really need to be loaded on anything that the Git fleet is serving, for example. How, like, is this part of this effort or not?
I'm kind of thinking that probably the best way to have like the biggest upside on the Composable code base is to try to go on how we run this on the infrastructure today. So feature separation. I mean, like clearly, you say Git. In the Git context, we really need a very small portion of the whole application. We need authentication service, scheduling of the side key workers. We don't really need anything else outside that. So I guess by definition, like feature implementation, we don't really need that in the Git context.
Not a lot.
If you consider that. The question is really like how you model this separation to not load that. And I think like we, Nicola, discussed like a way to structuralize that on the in the code base by, I don't know, having separate directories with the array scaffold, and basically maybe Git is another this kind of directory with this array scaffold that just has like the Git component. If you run a fully monolithic application, it's just gonna load more, but the feature you kind of need to share probably models because of the database structure. But the services, they read probably in the specific context of the execution, which is, I don't know, side key, or maybe part of the controllers, part in the GraphQL context. So I think this is my perception, that probably it's easier to think on the slicing that by the infrastructure, because it's much easier to reason what we need there. Slicing by the feature, we would actually kind of go more into microservices, which is another level of the complexity. How to figure out to do it.
But like that brings kind of a problem. Like we have an API fleet, for example, now, and a Git fleet, but those don't really mean anything, and that those are kind of like most of the traffic going to the API fleet is API traffic, but sometimes we miss a beat and it's web traffic because that's just naive HA proxy rules. That doesn't break anything now because the whole application runs there. So from an infrastructure perspective as well, we need to like isolate.
I know that's probably like baby steps, like start with something that is clear, like side key, because you know that you're not gonna cross use requests. I think like GraphQL API controllers, it's gonna be slightly harder, but
yes, and the benefit for Sidekick alone, like just doing this for Sidekick would already be quite big, because lots of them, like most of them, Skarbek can correct me if I'm wrong, but most of the Sidekick workers are like the minimum number of pods we spin up is for most of the time way too high, but we can't spin them up fast enough to cover peaks in traffic and different workloads. So,
and there are some workloads that we don't enable the horizontal pod autoscaler, just because we haven't done enough analysis on the performance characteristics of that workload to be comfortable that we could scale quickly enough in certain cases. I think from my viewpoint, I do agree that we do have some problems, like Bob mentioned, where if we try to break out parts of the code as necessary, we're going to have certain situations where our API, Git, and web fleets, those are specific to .com and not necessarily specific to self-managed instances or customers. So we're going to see less performance gains for self-managed in that realm. But if we could do that right for .com, I still think we could get some pretty cool benefits out of it, and we could probably make some improvements on the infrastructure side to help make that even better. As far as your original question of trying to figure out the impact of infrastructure cost, we would need to sit down and do a lot of math effectively. And even then, it's going to be a best guess scenario. It's not going to be perfect numbers. So I think if you want someone to take a look at those metrics and do some sort of deep dive, I would recommend spinning up maybe a dedicated issue. That way we get that scheduled. That's probably going to live somewhere with scalability or somewhere in delivery, since we did initial migration to Kubernetes. That could help you get started with understanding what the cost implications may be, and how that might drive how far deep you go into this project. And it sounds like you want that information ahead of time. But it's not going to be quick. It's not going to be something that we whip out in an hour. It's going to take probably
I think
a few
it's
days.
also hard to estimate like what the effect actually is going to be. Like as you mentioned, we have the problems where because we don't want to break anything for anyone. So I think we need to come up with a path of like, what would happen if we don't load this now? but then load it if we actually need it, and then see what doesn't get loaded in the end. Like there's already loads of stuff in Sidekick, for example, that we'd never get into memory, and then that would help.
So, like one of the ways that you can approach that, like, don't change anything in the current structure of the application, but really monitor what is being loaded and when and by who. So kind of like takes soft approach to try to remove all cases or maybe move things around into, let's say, explicit context, but this explicit context is still being actively used for loading, lazy loading classes, but approach that from the perspective that if you see it's being loaded, you actively find a place that caused this to be included. You kind of optimize on amount of the files being loaded in the process, and this is what you monitor, and this is you monitor kind of, I don't know, to kind of some sort of identification of the files in which context they should be used, and this is how you maybe monitor that via Prometheus metrics. You kind of actively fight to load as little as possible in the context based on you investigating, I don't know, via testing suite, QA, or whatever, what is needed. So I think that there may be an easier way than like we, Nicola, initially investigated with the full-fledged separation of the engines that maybe allow us to be softer in the preventing loading of some classes when we don't need them, or actively writing code in a way, or like fixing the code in a way that doesn't induce loading unless it is needed. And we basically become very strict, maybe in the development environment. Hey, you're running Puma. What you did, you actually caused like the half of the application to load. This is not what we want to have. So maybe I think there is like a number of ways how we could approach it, more iterative and simpler and less error prone, but still maybe start to see these benefits faster by monitoring what is being loaded when, by whom, try to annotate what is allowed, actively fight for these things to not be loaded. For example, we today load, I believe, flip GitLab database background migration in each process, something that we don't really need.
And from that perspective, Andreas, I was telling to Andreas about Rails engines, and he was very fond of us as a database group, moving everything, being one of the first group to move everything outside of to a separate engine, also for testing. It will be also very, very good for testing.
Yes, and probably like it's not even about the engine, it's more about like the clearly annotating, let's say maybe like the place that you store, because lib folder is like very drawback special purpose that we effectively load everything from the folder each time, even though we usually need probably half of that.
Yeah, that's true.
So effectively, we remove
I
everything
guess,
from the autoload path and then see what breaks.
not really. Like you keep autoload path, but maybe you structuralize that, or maybe you, I don't know. We have our comment with the frozen string dev, or maybe we add another comment saying application context, and we just start to be strict about like the context in which it should be used. I don't know. There's a number of ways how we could approach it. But for me, libfolder is very strong anti-pattern in its current form. And the fact that we kind of like, it's really contextless. And we started to put the random stuff that is used only by specific services, the specific execution path. So it kind of like creates a lot of pollution in the runtime, the lib folder today.
I agree, but the biggest concern I have, for example, I really like your idea to maybe look at the long-term solution, but I really find it hard to anticipate like all the nodes and how we run application, because I don't have experience and I don't know how our infrastructure is run, and then to predict like how we can split the application that way. And because I found like Grape API sounds like really simple thing to, I don't know, remove and extract, because it's definitely not used by Sidekick at least. So like just remove everything that is in Grape API folder and don't load it. But it turns out like in many places, even in Sidekick, you at least use the Grape API URLs
and stuff, yeah.
and roots. So yeah, that brings some problems that are not unsolvable, but probably yeah, sure.
like probably we like the solution for that is like really stuff for all of that you need. I don't know, but like I mean, like one thing to take a look at that, like I'm not sure if we have a graph that shows like the memory usage pattern from 1 year or like 2 years ago compared to now. In 2 years from now, this memory usage is gonna be probably 30 to 50% larger than it's today. And it's like by doing that, the application becomes exponentially slower. Why I started mentioning like these GC cycles, like GC cycle time effectively pauses all application or processing, so it increases your latency. And this is really bad thing, because at some point, application will become so big that it's basically gonna be stopping for 200 milliseconds and you can do nothing about that, because you cannot remove that from the memory. And like GC, even incremental, needs to work a lot of references, and it's simply gonna be slow. So I think there's really like the problem with our memory approach and the fact of the growth of the features. So what we actually may be doing now is, in 2 years, maybe we're gonna stay at the same level that we are today with the same performance. But if we don't do anything, in 2 years, application will be probably twice slower than it's today because of the memory consumption, GC, amount of the requests. And what we're gonna be doing there, we're gonna be, instead of running 4 threads, maybe per worker, we're gonna be running 1 thread per worker, because this is gonna only allow us a single predictable performance, the minimal latency. So what I'm kind of saying, like, it exponentially gets more expensive over time, because we're gonna be optimizing by throwing more capacity and reducing concurrency, and it's gonna be multiplying amounts of the memory and resources that we are using by that. So.
Yanis, do you have any comment from the product side, like how to present this and push it forward? Like,
I think that if we are, yeah, this is something to think about. The important thing is, first of all, for us to be sure. So it's before we go out and sell it, it's not about selling it. It's about us finding the best thing to do, I think, if everyone agrees, and making sure that that we know the path forward.
I think from the product perspective, maybe interesting approach could be look at the historical growth of the memory usage, try to extrapolate that by a number of the employees, and let's say try to correlate that with the number of the employees to the growth of the memory, and compare that with amount of the people we want to hire, let's say the 2 years from now. It kind of gives you a pretty rough estimation how much code we're gonna be adding and how much bloat into application. This is maybe that gives you idea how much more on the infrastructure side, given the growth of the customers we are expecting, because the growth of the memory usage plus growth of the customers is actually multiplication. So effectively, you may estimate savings that today's savings is maybe, I don't know, $100,000 per month, but in 2 years, given our growth of the customers, our addition of the features, it actually starts to become $1 million per month. And this is maybe how you can estimate that if we keep our memory usage at the current level, this is how much we would be saving. It's actually like it's a headroom for adding new features without the negative performance impact in a lot of cases.
I agree with you, Camille, but the problem is how finding this 100K. So if we had an analysis that we could show that we can save 100K per month, I'm pretty sure it will be very easy. My life will be very easy. Everybody will be on board. And this is part of this discussion that we're having right now. It's difficult to make sure that we're going to save off even 10K at the moment. So this is something that we have to understand. And it's not only, as I said, for selling it. It's also for us to know whether we're doing this as a restructuring that will help us grow as a project, which is very important, or if it is something that will also have impact on GitLab's performance and on our costs.
So how I can help you like find these numbers? Because there is like a number of benefits, really. Like, so what you need.
So those were also the questions by Nicola on the issue. So, for example, yeah, we say that we can go from 8 vCPUs to 6 vCPUs. Will that affect our costs, or that's not? It is not affecting anything, because either way we have to provision for 8 vCPUs. It's just a random thing. Or saving off 100 megabytes. We know that we can do that. Is it going to change anything on the resources used on the provision of the pods? Are we going to make pods less expensive? And then there are, for example, the boot up times. They are not going to affect our cost directly, but we can have an analysis and say that it will make, for example, our deployments faster, better. And maybe if we could find also an angle there. So, for example, if there is a plan, for example, and this is for John to discuss with us, if we could have instead save off a minute, we could do something different, completely different. It will block delivery to approach to have different schemes and strategies. I don't know.
I think, like Bob mentioned, like this is going to be very difficult to calculate. You know, we're subject to the way Kubernetes scales. We're subject to a lot of the methods for how GKE manages nodes and the pods that get scheduled, where they get scheduled. So we could certainly do an estimation, but it's only going to be an estimation. We're not going to be able to provide like strict hard numbers. We could probably say like, oh, we estimate we'll say between 10 and 20% of our production costs, which, if we could get that point, like that'd be great. But again, it's not going to be easy to investigate either. It's going to take some time and effort, because we do have a lot of Sidekick workloads, and we do segregate our web services in a way that if you don't know this, it may not be beneficial in certain regards. So maybe one thing we could start off with is a conversation. Nicola, I know you mentioned that you lack some of the experience with how we run our infrastructure. Maybe it would be wise to start that conversation with you and get you up to speed with how .com is running, how things are deployed, why we have them deploy the way that we do, because that might give you a better understanding of what specifically we need to look into, and that might give us a better route for determining what those infrastructure cost savings could potentially be and how we could arrive at those numbers. Would that be a good way to maybe start that conversation?
Yeah, I agree. At least from my perspective, for me, it will help.
Okay. So how about this? Maybe spin up a dedicated issue just to track this specific work. And, you know, we have a whole infrastructure team. Bob is certainly here. He's been here long enough. I'm sure he knows quite a bit. And certainly I could also help with answering those questions. Feel free to send a calendar invite in any which way you see fit. I think it would be easier if we did this via a synchronous call just to get you started, and some pointers to maybe some repositories to get into some finer grain detail for that kind of thing.
Cool, thanks, I appreciate it.
Nicola, if you need help, we can work together on the, let's say, long-term benefits, because this is what we discussed. It's like the first iteration. So we could maybe try to estimate if you would, let's say, run this project for 2 or 3 years, what would be the long-term benefits, and we could maybe then try to estimate benefits via that as well.
Yeah, that would be great. Thank you. Okay, we have at least like starting point, an idea how to, we don't have exact answers. I didn't expect to have exact answers, of course, but so I don't know. Yanis, do you have anything to add, or we can wrap it up?
No, thank you. It was very, very useful, and I think that it's at least from our perspective, it's very important if we manage somehow to start working on this, because I think that it will be beneficial in general for GitLab as a software project, and to find ways to.
Yeah, but what I liked about this approach is that it allows us to like iteratively like move code around and extract some components and play with it. At least maybe we can even start without actually moving the code, but adding measurements and like just loading those engines and see what's going on. So that's the good part, that we can like start small and move forward. But before we start like moving code around in different folders, it would be nice that we know like that we want to do it, because yeah, it's changed and it will be hard for other developers as well. And I don't know, it's a big initiative, like that there will be a lot of work if we choose to do it. And
I think if the infrastructure, I mean, that application side of the infrastructure is done, that I don't think it will be much harder for developers, like, because they will have, like, they will be more contained and they will not be confused and put it like the answer is not going to be, I'm going to just add a file to libgitlab and
yeah, that's a good point.
But they will have their own libgitlab where relevant things live.
Maybe you have a top level sidekick class folder with a deep GitLab in it, and it kind of indicates this is only loaded in the sidekick context, or specs if you prefer. And maybe this is how you approach that. Maybe the same goes for we have, I don't know, web initially, and we kind of start to move things around. We initially have the load paths to use all folders, but we kind of monitor for time being if we are cross-loading things that we should not be loading.
Yeah, just knowing where things are get loaded from, and if that makes sense, like, yeah.
Like the biggest problem is really like classifying stuff. If you move things around and you kind of figure out a good way to classify that is like predictable for people writing code and predictable for application, which I clearly think that folder is probably the most predictable way to classify stuff. I guess then it kind of becomes pretty also like a good indicator like for people writing. If they want to write side key worker, they just put their stuff in the side key worker with all related services. We just provide some magic to allow them to execute the side key worker from asynchronously from whatever context they need, and it just works. But by you being explicit when you create new files, we actually have much more structured approach that is much more scalable. I kind of start to hate like this very flat structure that it doesn't kind of define what you need to use where. That's how Rails works, but I think it doesn't scale very well like very big applications that are as GitLab. So it's convenient, but the best optimization is simply not do something instead of trying to optimize whether you should be doing or not.
That's true. I don't know, like, but you mentioned like the lib folder are not gonna be like, it's not gonna disappear. So we will need to make sure that adding new stuff is needed to be added to the correct space and not put again in the lib folder. But this can probably be solved by, I don't know, some Rubico Pro, or I don't know, DangerBot on the MR. Do not put things that are not common in the lib folder anymore.
So maybe lib folder will not move away. It's like maybe we have lib folder in the specific context simply, and we are being very naive and we just move things around. And if you really want at some point to share that, you kind of move files. Moving files in the Git is pretty straightforward. And if you are merging stuff and applying new changes, Git does that for you and discovers like what was changed and when. So I think the problem with the lib folder is like a multi-purpose. The purpose of like providing low-level helpers, the purpose of providing the framework extensions, the purpose of providing business logic to different parts of the application. And it kind of makes it really hard to split that because I don't know, we in the lib folder, in the same place, we have a way to parse CI config. We have a way to generate metrics generation that is used only in a very specific context. And we also have like a queuing mechanism that is used only in the API. So there is like a ton of examples in the lib folder that it's like a drawback. Like you kind of throw there everything that you cannot really classify where it should be living, and it kind of. I know this is how you're writing Rails, but I think it's not sustainable in GitLab, big monolithic application. But you should also look at the pods discussion, because in the pods discussion, what we may be doing in the future is like we're gonna be running smaller instances instead of like a very single big instance. We may be moving some components out of the GitLab, I mean GitLab Race, or maybe running a subset of the GitLab Race to provide some functions to share data. But basically pods moves away from a single big application into a lot of small full stack applications. So maybe in the pod world, we're not gonna have so much granularity on the infrastructure level. Maybe we're gonna be running that closer to how like Helm charts are configured today. Because instance, for example, processes 1,000 or like 100,000 users is just fine to run on the 3 or 4 nodes in total with the volume of traffic it's processing. So this may be also impact how we may want to scale GitLab from the memory perspective and running. So this will be another hint. But I'm pretty sure that one thing will not go away. Lib folder, side key, and web, or lib, Puma, and side key. These are, I guess, three main components that will always stay as is, regardless of what we do with pods.
Okay. Thank you all for joining and for all the insights that you provide. Thanks, John. I will create a separate issue, and yeah, Camille, we will continue discussion on the grand scale impact for the future. And thanks once again for your time. I really appreciate it.